you have a function with 3 inputs and 1 output, then in order to visualize the graph, you would need 4-dimensional space, right? So since we're not good at visualizing that, we can't really see the graph on this function because the graph requires seeing the inputs and the outputs. But we can still visualize this function. If we remember what we did in the case with a function from R2 to R1, we were able just to visualize the inputs. So we looked at the contours or the level curves of that function, and then we could depict it, and we could depict that 3-dimensional surface in just 2 dimensions. We can do something similar with this function. So we can look at the level curves. So look at the level curves of this function. Let's give an example. Suppose we have our function. It has 3 inputs, x, y, and z, and from those inputs we have to get a single output. So maybe we could look at this function, x squared plus y squared plus z squared. We can't see the graph because that would require 4 dimensions, but we could look at the level sets. So we could say, what are all the locations in the input space, right? What are all the locations where the output is 1? Or what are all the locations where the output is 2? Or what are all the locations where the output is 3? Now each of these we recognize as a sphere, right? So we can see something about this function. So all the points where the output is 1, that's a sphere of radius 1. All the points where the output is 2, that's a sphere of radius root 2. All the points where the output is 3, that's a sphere of radius root 3, and so on. So we can't see the actual function, but we can see the level sets. That's important because if we have a function and we want to find the biggest value, then we could look at a level set and sort of see how are we going to get to bigger values for that function. How are we going to optimize this function? In this case, we can see the level sets, since they're nested spheres. The way to increase this function is to move out in this direction, right? Move perpendicular to these level sets would allow us to grow. So the level sets do allow us to visualize something about the function, but it's not a graph, right? The graph would be the inputs with the outputs. We're just looking at just the outputs that give a particular output value. And then that gives us a sense of what this function's like. If you think about what this function does, it really measures the square of the distance from the origin. And so as we increase the output, we're just asking what functions are further and further and further away, and they all kind of go in these nested spheres, right? These are all the points that are 2 away from the origin. That would be the level set that corresponds to w, or a variable, whatever the output variable is. W equals 4, right? This is the w equals 3 level set, and the w equals 2 level set. It's a lot like a contour map. It's sort of the analogous thing. The contour map, you have your location in the plane and then an altitude, and you look at the contours, which are level curves. Now we have level sets or level surfaces as our visualization for a function with 3 inputs and 3 outputs. Now an example of one of these functions with 3 inputs and 3 outputs that's linear might be something like this. Maybe our output is this function g, right? And we have our 3 inputs. We use them somehow in a linear way to create our output. So maybe this is our function g. Again, we can't see the graph because there are 3 inputs, 1 output. To see the inputs and outputs together would require 4 dimensions, but we can ask about the level curves. So we could say, well, what about 2x plus 3y plus 2z? What are all the values where the output is 0? Or what are all the values where the output is 1? Or what are all the values where the output is 2? So we can look at level surfaces again. For these are all planes, right? And they're all planes with the same normal. The normal goes out 2, over 3, and up 2. So let's see, I could depict that normal vector with its tail at the origin in this way. So here's our normal. So when 2x plus 3y plus 2z equals 0, that's the plane perpendicular to that normal through the origin. And then we just have a sequence of planes as we move farther out. And this is the level set. So if we call our output maybe w, it's our fourth number, the number that comes out of this. This is the level set that corresponds to w equals 0, and then we have the w equals 1 level set. And then in a plane parallel to that, we have the w equals 2 level set, and so on. So these level sets are useful still, because we can see, all right, if you want to increase the output of this function, then you should move in this direction, right, through those level sets in the direction of increasing w. Or if you want to decrease, then you should go through those level sets this way, go in the direction of the normal, but go this other way, go backwards to the normal.